Imagine a weapon that doesn't rely on sheer explosive power or wide-area destruction, but instead on intelligence, accuracy, and timing. A weapon designed not just to hit a target, but to hit the right target. This is the world of precision-guided munitions, often called PGMs, and they have fundamentally changed how modern wars are fought. In today's conflicts, success is no longer measured only by firepower, but by how precisely that firepower can be delivered. Precision-guided munitions are weapons that use advanced guidance systems to steer themselves toward a specific target with a very high degree of accuracy. Unlike traditional, dumb, bombs or unguided rockets, which simply fall where gravity and basic ballistics take them, PGMs can adjust their path in flight. This means fewer weapons are needed to achieve the same effect, collateral damage can be reduced, and military operations can be conducted with far greater control. In simple terms, PGMs are the difference between saturating an area with explosives and striking a single building, vehicle, or even a specific room. The idea of precision in warfare is not entirely new. Even in ancient times, commanders sought ways to strike enemy leadership or key assets rather than entire armies. However, true precision-guided weapons only became possible with modern electronics, sensors, and computing power. Early experiments appeared during World War II, when some guided bombs were developed, but the technology was limited and unreliable. It wasn't until the late 20th century that PGMs began to prove their true value on the battlefield. One of the most important moments in the history of precision-guided munitions came during the Vietnam War. Laser-guided bombs were introduced, allowing aircraft to strike bridges and harden targets that previously required dozens of sorties. These weapons used laser designators, where a target was painted with a laser beam, and the bomb followed the reflected energy to impact. This was a revolutionary concept at the time, and it demonstrated that accuracy could dramatically change air warfare. At the heart of every precision-guided munition is its guidance system. Different PGMs use different methods to find and track their targets. Laser guidance relies on reflected laser energy, but it requires a clear line of sight and can be affected by weather such as clouds, smoke, or dust. GPS guidance, on the other hand, uses satellite signals to guide a weapon to fixed coordinates. This allows for all-weather capability and has become extremely common in modern air forces. Infrared guidance tracks heat signatures, making it useful against vehicles, ships, and even aircraft. Radar guidance uses radio waves and is especially effective against moving targets, including those at sea or in the air. Each guidance method has strengths and weaknesses, which is why modern militaries often combine multiple systems in a single weapon. A bomb or missile may use GPS for mid-course navigation and switch to laser or infrared guidance in the terminal phase. This layered approach improves accuracy and resistance to countermeasures. If one guidance method is disrupted, another can still guide the weapon to its target. Precision-guided munitions come in many forms. Air-dropped bombs are among the most well-known, ranging from relatively small weapons to massive bunker-busting bombs designed to penetrate reinforced structures. Missiles are another major category, launched from aircraft, ships, submarines, or ground vehicles. These can be used for air-to-ground, air-to-air, surface-to-surface, or surface-to-air roles. Even artillery shells and mortar rounds can now be precision-guided, allowing ground forces to strike targets kilometers away with remarkable accuracy. One of the key advantages of PGMs is their ability to reduce collateral damage. In urban environments, where civilians and infrastructure are close to military targets, traditional weapons can cause widespread destruction. Precision-guided munitions allow commanders to strike specific enemy positions while minimizing harm to surrounding areas. This is not only a tactical advantage but also a political and ethical one, as modern conflicts are fought under intense global scrutiny. Another major benefit is efficiency. With unguided weapons, multiple bombs might be required to destroy a single target. With PGMs, one weapon can often achieve the same result. This reduces the number of sorties, saves resources, and lowers the risk to pilots and ground crews. It also shortens conflicts by enabling rapid and decisive strikes against key enemy capabilities. However, precision-guided munitions are not without limitations. They are significantly more expensive than unguided weapons, both in terms of production and maintenance. Advanced electronics, sensors, and guidance components drive up costs. In large-scale conflicts, where vast numbers of targets must be engaged, relying exclusively on PGMs may not be economically feasible. As a result, many militaries maintain a mix of precision-guided and conventional munitions. PGMs are also vulnerable to countermeasures. GPS-guided weapons can be affected by jamming or spoofing, where false signals are used to mislead the weapon. Laser-guided munitions can be disrupted by smoke screens or weather conditions. Infrared seekers can be confused by flares or other heat sources. As a result, the ongoing contest between precision weapons and defensive countermeasures continues to evolve. The impact of precision-guided munitions on military strategy has been profound. They have enabled concepts such as shock and awe, where rapid, precise strikes are used to paralyze an enemy's command structure and critical infrastructure. Instead of prolonged campaigns of attrition, modern forces aim to disable the enemy's ability to fight by targeting leadership, communications, logistics, and air defenses early in a conflict. Naval warfare has also been transformed by PGMs. Anti-ship missiles with advanced guidance systems can strike vessels from hundreds of kilometers away, forcing navies to invest heavily in air defense systems and electronic warfare. On land, precision-guided artillery allows ground forces to engage targets with minimal exposure, changing how battles are fought at the tactical level. Unmanned systems have further expanded the role of precision-guided munitions. Drones can carry small, highly accurate weapons and loiter over an area for extended periods, waiting for the right moment to strike. This combination of surveillance and precision firepower has reshaped counterterrorism operations in modern battlefields alike. Looking to the future, precision-guided munitions are likely to become even more advanced. Artificial intelligence and machine learning are being explored to improve target recognition and decision-making. Networked weapons may share data in real time, coordinating attacks and adapting to changing conditions. Hypersonic weapons, traveling at extreme speeds, are also being developed with precision guidance, presenting new challenges for defense systems. At the same time, ethical and legal debates continue to surround the use of these weapons. While precision reduces unintended damage, it also lowers the threshold for the use of force in some cases. The ability to strike with minimal risk can make military action more politically acceptable, raising questions about accountability and escalation. Precision-guided munitions represent one of the most significant shifts in military technology in modern history. They reflect a broader trend toward smarter, more selective use of force, where information and accuracy matter as much as raw power. As technology continues to advance, the role of PGMs will only grow, shaping not just how wars are fought, but how nations think about the use of military force itself. In the end, precision-guided munitions are more than just weapons. They are symbols of a new era of warfare, where decisions are measured in meters instead of miles, and where the outcome of a battle can hinge on a single, perfectly guided strike.